Hello everyone, welcome to Coders Camp. So today we are here at the fourth video of our recursion series. In our previous videos we have seen the basics of recursion, how does recursion work, and few problems that can be solved using recursion technique. So here we are going to learn the recursion used with memoization. So what is memoization? Memoization is an optimization technique generally used to store values which are previously computed in order to speed up your program. So to understand that, we are going to see the classic example of recursion, the Fibonacci series. Before getting into memoization, we need to understand how Fibonacci series work and how recursion code of Fibonacci series work. To start with Fibonacci series, now Fibonacci series of 1 is going to be 1, 2 is going to be 1 again, 3 is going to be 2, and 4 is going to be 3, 5 is going to be 5, and 6 is going to be 8, and goes on. So here this actually works by adding previous two values. That is fib of 4 is going to be adding fib of 3 and fib of 2. That is 2 plus 1 is equal to 3. Similarly, fib of 6 is going to be adding the previous two values, that is fib of 5 and fib of 4, which is going to be 5 plus 3, 8. So here the recurrence relationship we have found is if fib of a number n is going to be fib of n minus 1 plus fib of n minus 2. So let's code this recursively to understand memoization. So now we have known, we declare result, and the result is going to be, if fib of n we are going to find, then it is going to be fib of n minus 1 plus fib of n minus 2. So this is a recurrence relation. We are going to return the result. So to stop this problem from running further, we need to put our base condition. That is, the base condition here is, as we know, the fib of 1 and fib of 2 is going to be 1. So we are going to check if n is less than 2, then return 1 or return n. Anything would do. So simple, we just wrote the program to call the fib of n minus 1 and n minus 2 every time, and then if n becomes less than 2, in this case return n, and send the result. So let's run and submit. So this actually runs in 6 milliseconds. So let's understand how actually Fibonacci series call its functions. Consider our n is equal to 5. So our Fibonacci series starts calling fib of 4 and then fib of 3 and add both of its result. So when you call fib of 4, it is going to call fib of 3 and fib of 2, and further fib of 3 is going to call fib of 2 and fib of 1. Similarly, fib of 3 is going to call again 2 and 1, and then fib of 2 is going to call 1 and 0, and further these three is going to call and return the value from 2. So if you observe, calculating fib of 3 is repeating twice, fib of 2 is repeating twice, fib of 1 is also repeating thrice at every place. So in this case, we are doing duplicate operations or doing repeated number of operations in place where we don't need to do. So to reduce that, we are going to use memoization. So here, as I said, memoization is an optimization technique which stores the values which are already computed in order to retrieve it when we need it. So we are going to declare and map, which is gonna hold integer values. So now every time we calculate our result, we are going to update our map. That is their n and the result. For that particular n, what is the Fibonacci value of that n? So as we have put a result in our map, we are going to check or retrieve it every time we encounter it. That is, if map is having that value already, we are not going to call the function, we are simply going to return the value from the map. So yes, we have declared a map and stored all our results. So every time when a n is already computed and stored, we are going to retrieve the value directly instead of calling the function. So by doing so, it is not gonna call the function and create a memory space in our call stack. Instead, it's just simply going to retrieve the value in linear time from our map. So here, as I have used map, instead map you can use any data structure, either it can be arrays or set according to how you are implementing memoization. So let's run this now. To understand memoization, we have taken the example of Fibonacci series, but there are few problems where we actually implement the memoization and know the advantage of it. So wait for some more videos that includes recursion technique with memoization. So if you like this video, hit like and subscribe. Thank you.